Antimatter represents the maximum energy density allowed by physics. In theory, a single gram could push a spacecraft beyond the solar system, yet it almost never survives in nature. The universe did not preserve it. It allowed it to disappear. This is not a story about faster-than-light travel. It is a failure analysis. A report on why chemical rockets trap us near Earth, why the early universe collapsed into imbalance, and why we are now trying to manufacture a substance that thermodynamics actively destroys. We are designing an engine with no safe abort mode, no graceful shutdown. So before we ignite the core, we must ask the only forensic question that matters. Why was antimatter never meant to last, and what is the cost of forcing it to? If we are willing to force antimatter back into existence, it is because every conventional way of leaving Earth has already failed. That failure is not political or economic, it is mechanical. To see it clearly, look at the Saturn V launch. It feels like the ultimate expression of human power. To a flight dynamics engineer, it is a display of humiliating inefficiency. To send a tiny capsule to the moon, we had to build a skyscraper filled with explosive chemicals and burn it to the ground in minutes. The Saturn V weighed nearly 3,000 tons at liftoff. 85% of that mass was propellant. This is the tyranny of the rocket equation, first formulated by Konstantin Tsiolkovsky in 1903. To go faster, you must carry more fuel. That fuel has mass, and lifting that mass requires even more fuel. It is a parasitic logistics system. You are forced to burn the majority of your propellant just to lift the remaining propellant off the ground. For 60 years, we have been trapped in this cycle. We have optimized chemical engines to their thermal limits, squeezing every ounce of energy from hydrogen and oxygen. The best chemical rockets achieve a specific impulse of around 450 seconds. It is enough to orbit Earth, barely enough to reach Mars, but completely useless for the stars. Chemical rockets are essentially controlled combustion, a primitive bribe to gravity, with sharply diminishing returns. We have hit a technological plateau. We cannot refine the chemistry further. We need to break the physics. To achieve interstellar flight, to reach a significant fraction of the speed of light, we need an energy density not 10 times greater, but 10 billion times greater. We need a reaction that doesn't just rearrange electron bonds like chemistry, but one that unbinds mass itself. The laws of physics allow for such a material. It is the absolute limit of energy density, total mass to energy conversion. But while the equations say it should be everywhere, our telescopes see a universe made only of matter. The fuel we need seems to have been systematically removed from reality. The material we need is not missing because it is impossible. It is missing because something went wrong at the beginning of time. To find it, we have to go back to a glitch in a mathematician's notebook in 1928. In 1928, the British physicist Paul Dirac was attempting to merge quantum mechanics with special relativity. He was looking for an equation that could describe the behavior of an electron moving at close to the speed of light. He found it. The Dirac equation was elegant, symmetrical, and mathematically perfect. While working through the equations, he noticed a disturbing anomaly. The equation relied on a square root relationship for energy, where energy squared equals momentum. Squared times the speed of light squared plus mass squared times the speed of light to the fourth power. In mathematics, the square root of a number always has two solutions, a positive and a negative. The square root of 4 is 2, but it is also 2. Most physicists of the time would have discarded the negative solution as a mathematical artifact, noise in the signal. Energy, by definition, was a positive quantity. But Dirac possessed a unique kind of theoretical courage. He trusted the math more than he trusted common sense. He realized that this was not a mathematical error, but a physical implication. The equation was telling him that for every particle of matter with positive energy, there must exist a corresponding shadow particle, a mirror image with the same mass but opposite electric charge. Dirac had discovered the shadow solution to reality. He predicted the existence of the anti-electron. For 4 years, this remained a ghost story, a theoretical phantom haunting the chalkboard. Then in 1932, the ghost left a fingerprint. At Caltech, American physicist Carl Anderson was studying cosmic rays using a device called a cloud chamber. This apparatus was essentially a trap for invisible particles, a sealed vessel filled with supersaturated vapor. When a charged particle zipped through it, ionized the gas, leaving a trail of condensation behind it, like the contrail of a high-altitude jet. Anderson placed a strong magnetic field across the chamber. He knew that a magnetic field forces charged particles to curve. Negatively charged electrons curve one way, positively charged protons curve the other. On August 2, 1932, Anderson captured a photograph that violated the known rules of the game. The track had the curvature radius of a lightweight electron, but it bent in the wrong direction. It was moving as if it were positive. It couldn't be a proton. It was too light. It was exactly what Dirac had seen in the numbers, an electron with a positive charge. Anderson named it the positron. The discovery confirmed that our material world is only half of the picture. We now know that every fundamental particle has an antimatter twin, an antiproton for every proton, an antineutron for every neutron. In theory, an antimatter world would follow the same physical laws as ours as long as the two never touched. This was the first forensic breakthrough. We had found the weapon, the mechanism of creation. But this discovery immediately opened a much darker line of inquiry. If matter and antimatter are born in identical pairs and the laws of physics are symmetrical, then the Big Bang should have produced equal amounts of both, and they should have emerged in perfect balance, and then moments later they should have collided. We had identified the anomaly. Now we had to explain the absence. To understand why we don't see antimatter galaxies floating next to ours, we must examine the mechanism of contact. When a particle of matter meets its antimatter counterpart, say an electron colliding with a positron, they do not bounce off each other. They do not bond chemically. They undergo a process called annihilation. This is the most energy-dense conversion process nature allows. In nuclear fission, the process behind atomic bombs, only about 0.1% of mass becomes energy. In nuclear fusion, the process that powers stars, that number rises to 0.7%. But annihilation is different. It is 100% efficient. The entire mass of both particles vanishes and becomes high-energy gamma radiation, exactly as Einstein predicted when he showed that mass and energy are the same thing. Nothing is left behind. Now consider the Big Bang. 13.8 billion years ago, the universe was a singularity of infinite temperature. As it expanded and cooled, pure energy condensed into particles. The laws of physics, as we understand them, demand symmetry. For every quark created, an anti-quark should have appeared. For every electron, a positron. The universe began as a perfect mixture, 50% matter, 50% antimatter. If the system had functioned perfectly, these opposing forces would have instantly recombined. They should have annihilated each other down to the last atom within the first fraction of a second. The result would have been a universe filled with nothing but light, a vast sterile bath of radiation, with no stars, no planets, and no observers. It would have been a total cancellation event. The fact that we are here to discuss this implies that the cancellation was incomplete. The forensic evidence is written in the cosmic microwave background radiation, which is the thermal relic of that primordial interaction. Something went wrong in the early universe's production line. In 1967, Soviet physicist Andrei Sakharov proposed the criteria for this anomaly known as the Sakharov conditions. He suggested that the laws of physics are not perfectly symmetrical. There must be a violation of charge parity symmetry known as CP symmetry, a subtle bias in the weak nuclear force that treats matter and antimatter differently. Experiments at CERN, specifically with the LHCb detector, have confirmed this suspicion. We have observed that certain heavy particles like B mesons decay into matter slightly more often than into antimatter. The difference is minuscule in a symmetry of less than a few percent in specific interactions, but on a cosmic scale, that microglitch was everything. For every 1,000 particles of antimatter created in the Big Bang, the universe created 1,000,001 particles of matter. 1 billion pairs annihilated each other, filling the cosmos with light. But that single solitary +1 particle had no partner to annihilate with. It remained. We are that survivor. Every star in the sky, every planet, every atom in your body is made of the leftover debris from that great annihilation. We are the statistical error that the system failed to delete. This leads us to a sobering conclusion about the nature of our fuel. Antimatter is not a natural resource. It does not exist in mines or nebulas waiting to be harvested. The universe systematically selected against it. It is a substance that has been thermodynamically evicted from reality for 13.8 billion years. And this brings us to the crux of our engineering problem. To build an antimatter engine, we cannot simply find this fuel. We have to recreate it artificially. We have to reverse the flow of entropy and force nature to accept something it rejected at the dawn of time. At the border of France and Switzerland, inside a 27-kilometer ring buried underground, humanity is attempting to override this cancellation code. At the European Organization for Nuclear Research, known as CERN, the mission is theoretically simple: recreate conditions that no longer exist in nature. In practice, it is an act of brute force industrial engineering. Inside the antiproton decelerator facility, often called the antimatter factory, physicists smash protons into a block of iridium at velocities approaching the speed of light. The kinetic energy of this collision is sufficient to create particle-antiparticle pairs from the vacuum. It is a modern alchemy converting motion into mass, but the yield is pitiable. For every million collisions, we might harvest a handful of antiprotons. These particles emerge screaming with kinetic energy, moving too fast to be caught. To store them, we must slow them down from near light speed to a standstill without letting them touch the walls. We use magnets to cool them, tame them, and trap them in a vacuum deeper than interstellar space. This process reveals the grim economic reality of antimatter. It is not a fuel source. A fuel source like coal or uranium gives you more energy when you burn it than you spent digging it up. Antimatter is the opposite. Consider the energy audit. To produce a single antiproton, we must accelerate trillions of protons. We power the magnets, the cryogenics, the detectors, and the data centers. The energy conversion efficiency is approximately 10 to the minus ninth. That means for every 1 billion units of energy we pour into the grid at Geneva, we successfully capture only 1 unit of antimatter energy. The rest is lost as waste heat. This is not mining. This is energy laundering. We are taking vast amounts of cheap electrical energy from the French and Swiss grids and compressing it into a microscopic form with ultimate density. Current estimates suggest that producing 1 gram of antihydrogen would cost approximately $62.5 trillion. That is roughly 2/3 of the entire global economy. If we ran the Large Hadron Collider solely for the purpose of making antimatter, it would take longer than the current age of the universe to produce that single gram. This reality check invalidates the sci-fi concept of harvesting antimatter from space. Unless we find a primordial cache, which Chapter 2 suggests doesn't exist, we are stuck manufacturing it. But let's assume for the sake of the investigation that a future civilization solves the energy cost. Maybe they build a Dyson swarm around the sun to pay the electric bill. They produce the fuel. Now they have to deal with its physical properties. For decades, science fiction speculated that antimatter might possess anti-gravity, that it might fall up. If true, this would shatter Einstein's theory of general relativity and offer a loophole for propulsion. In late 2023, the AlphaG experiment at CERN finally put this question to the test. They trapped antihydrogen atoms in a vertical magnetic bottle, then slowly turned down the fields, releasing the particles. They watched to see if the antimatter would float to the ceiling or drop to the floor. The results were a triumph for Einstein and a disappointment for dreamers. The antimatter fell down. It accelerated at approximately 0.75 g, within the margin of error of standard gravity 1 g. This confirmed the final classification of our substance. Antimatter is not magic. It possesses mass, it obeys gravity, and it requires astronomical energy to synthesize. Therefore, in the context of interstellar engineering, antimatter is a battery. It is the densest battery physically possible, capable of storing 9 times 10 to the 13th joules per gram, but it is a battery that must be charged at a massive loss. We have built the ultimate storage device. We have spent a civilization's wealth to fill it. Now the engineering team faces the final constraint, integrating this battery into a spacecraft. Once it is loaded, there is no fail-safe shutdown. We have now arrived at the operational phase. We have the fuel, a volatile reagent that cost a planetary economy to produce. We have the containment vessel. Now we must install it into a propulsion system. This is where the engineering reality shifts from difficult to terrifying. in traditional aerospace safety engineers design systems with a fail-safe mode. If a chemical rocket engine malfunctions, valves close pumps shut down, and the propellant sits inertly in the tank. The system defaults to a safe state. An antimatter engine is a non-fail-safe system. Its default state is detonation. To keep the ship from vanishing, active systems must function perfectly every second of every year of the voyage. There are three primary failure modes that define the lethal architecture of this machine. We call them the triad of risk, containment, momentum, and thermodynamics. Failure mode, a loss of containment. The integrity, breach. The fuel tank of an antimatter starship is not a physical box. It is a penning trap, a complex lattice of electric and magnetic fields suspending a cloud of antiprotons in a vacuum tighter than deep space. The walls of the trap are immaterial, generated by superconducting electromagnets cooled to near absolute zero. Inside this magnetic bottle, the antimatter remains suspended. As long as the magnets hum, the antimatter remains levitated far from the physical walls of the chamber. The failure scenario is known as a magnetic quench. If a microscopic defect in the superconducting wire generates heat, the material instantly loses its superconductivity. Electrical resistance spikes. The current crashes. The magnetic field collapses. In a chemical rocket, a tank leak means you lose fuel. Here, if the field collapses, the fuel expands at thermal velocities. It touches the physical walls of the trap. The result is an immediate release of the stored energy. This dictates the grim logic of the zero abort protocol. If the containment system detects a failure, you cannot jettison the core. You cannot vent the fuel into space. Because the nozzle itself is matter, the fuel would detonate inside the plumbing. You are trapped in a room with a bomb that you cannot defuse and cannot throw away. The crew's survival depends entirely on redundant power supplies and quench protection circuits. You are not riding a vehicle, you are balancing on a knife edge of electromagnetism. Failure Mode B, the momentum trap, the thrust deficit. Let's assume containment holds. We now feed the antimatter into the reaction chamber to generate thrust. Here we encounter the second failure, the physics of momentum. Novice engineers often assume that because antimatter releases pure energy, it automatically equals maximum speed. This is the flashlight fallacy. If you mix matter and antimatter and electron and its opposite, the result is gamma radiation, pure light. That light carries enormous energy, but it carries almost no momentum, which means the physical push you get from a photon is vanishingly small. A pure antimatter beam core engine is essentially a flashlight with the power output of a star. It shines brilliantly, but it produces almost no thrust. You would have a ship with infinite horsepower and zero torque. You could burn your entire fuel reserve and barely move the ship's mass. To solve this, we must introduce impurities. We don't use pure annihilation. We use the reaction to superheat a working fluid, usually liquid hydrogen, or we rely on the creation of heavy charged particles, called pions, to provide the kick. We mix antiprotons with protons. When matter collides with its opposite, the reaction erupts into a spray of heavy charged particles. Those particles race away at nearly the speed of light. Because these pions have electric charge, we can grab them with a magnetic nozzle and shoot them out the back. This provides the thrust, but this solution leads directly to the third and most absolute failure mode. Failure Mode C, the gamma furnace, thermal runaway. This is the killer. This is the primary reason antimatter propulsion has never moved beyond theoretical designs. When protons and antiprotons collide, the reaction explodes into chaotic quantum shrapnel. Some of it becomes charged particles that can produce thrust. The rest becomes neutral particles that cannot be controlled. The neutral pion is a ghost. It has no electric charge. Magnetic fields cannot steer it. It ignores the magnetic nozzle completely. Its lifespan is only 10 to the minus 17th seconds before it decays. When a neutral pion decays, it does so violently. It disintegrates into two high-energy gamma rays. A significant fraction of the total energy released becomes these gamma rays. They do not shoot out the back of the ship. They explode omnidirectionally like a miniature star, igniting in the center of your vessel. Imagine an engine producing the power of a small country. Now imagine 40% of that power instantly turning into hard radiation that passes through the walls of the engine as if they were made of glass. This is the thermal debt. The gamma rays slam into the ship's structure, turning the hull into a particle shower and dumping massive amounts of heat into the frame. If you cannot get rid of this heat, the ship doesn't just get warm, it vaporizes. A realistic antimatter starship does not look like the sleek Enterprise. It looks like a needle hiding behind a massive umbrella. The crew module must be separated from the engine by a shadow shield, a slab of tungsten or depleted uranium meters, thick casting a radiation shadow where life can survive. Behind the shield, the ship must deploy immense radiators' wings of cooling fluid larger than football fields, glowing white-hot to radiate the waste heat into the vacuum. This is the ultimate irony of the failure. We built the engine to go fast, but the faster we want to go, the more antimatter we burn. The more we burn, the more gamma rays we create. The more gamma rays, the heavier the shield and radiators must be. The heavier the ship, the harder it is to accelerate. It is a thermodynamic chokehold. The engine fights itself. The crew of such a vessel would live in a perpetual state of high-alert survival. First, they are strapped to a magnetic bottle that cannot be turned off. This is failure mode, a loss of containment. Second, they are pushing a mountain of shielding mass. This is failure mode B, the momentum trap. And finally, they are flying directly in front of a continuously detonating nuclear explosion. This is failure mode C, the gamma furnace. This heat, this blinding gamma radiation that forces us to hide behind tungsten shields, it feels familiar. It is the same radiation that flooded the universe 13.8 billion years ago. The thermal load melting our radiators is the echo of the total cancellation event. We've come full circle. We are attempting to repurpose the same physical process that eliminated antimatter at the beginning of time, this time under human control. The investigation closes in a perfect circle. We began by looking for a way to break out of the gravity well, and we ended up examining the physical process that created the universe. The story of antimatter is not merely a story about fuel, it is a story about the fundamental architecture of reality. Consider the symmetry. 13.8 billion years ago, the universe broke its own mirror. A violation of charge parity symmetry allowed a fraction of matter to survive the great annihilation. That debris formed the galaxies, the stars, the Earth, and the engineers who now stand in the tunnels of CERN. Today, those engineers are using the debris of the first explosion to reconstruct the missing half of matter's symmetry. We are forcing matter and antimatter back together, attempting to reenact the Big Bang on a microscopic scale. This is the Prometheus loop. We are using the glitch that saved us to recreate the perfection that tried to destroy us. The conclusion of this failure report is stark. Antimatter is not a magic key to the stars. It is the ultimate test of a civilization's maturity. The universe has set a rigorous exchange rate. Gravity offers us safety, but it demands we stay small, trapped in our chemical prison. Antimatter offers us the galaxy, but it demands we master the most unforgiving laws of thermodynamics. It requires us to live next to a fire that can never be extinguished, only contained. There are no shortcuts in physics. There is no free energy. To leave our cradle, we must be willing to pay the full price. We must accept that the engine which carries us to the future is built from the same dangerous symmetry that forged our past. We have to stop looking for a safe way out. In the end, the only way past the rocket equation is to accept its consequences.